What's going on, guys? Welcome to this Python tutorial series number 7.3. And today we're going to be talking about sets in Python. So without further ado, let's start. When we talk about sets, this has no difference with the set that we've taken in high school or we're currently taking. So basically, it has functions such as intersections, union, complements, sub sets, and there's so much more like in high school, right? So let's talk about its characteristics. Now, set lets us store multiple items in a single variable, just like the list and tuples, but it is immutable. Okay, which means we cannot alter or change the elements inside the set, but you gotta keep in mind that the set itself is mutable, which means we can add and remove items from the set. Okay? It is also unordered, which means it does not have a defined order, so every time we run the program, the order will change. Alright? It does not allow duplicates as well. So basically, if you put a duplicate value inside a set, the duplicate value or one of the duplicate values will be ignored. Okay, so it is also unindexed because it is unordered. So there's no definite position for the elements um, to be indexed. All right. So to create a set, you're just going to use what we call the curly brackets. Okay. And also we have set constructor just like in the lists and tuples. So we have set function. Okay. So let's talk about its functions. There's a lot of functions in sets. Okay. And one of them is called add function. Now when you use this add function, it adds an element to the set. So let's say we have sets variable here, and this is going to contain a set. So we have curly brackets, and let's just put two integers here. So let's say 23 and 45, and then bunch of strings maybe. So we have Raven John, and also um, a float. All right. Okay. So let's use the function add in a set. So to do that, you use the dot operator. So let's call sets dot add, and basically here you are going to specify the element that you want to include inside this set. So let's say I want to add 50 inside this set. Okay, so let's print this out. So let's see. So as you can see, we have 50 inside this set now. All right, and I want to just point out that if you run this in different times, so as you can see, it's changing every time. All right, that's why it is unordered. All right, so let's proceed to the removing functions in sets. So we have discard and remove. There's one more, but I'm going to talk about these functions first because they are confusing. Okay, so let's say I want to remove an element. Let's say 45 here. So let's use the discard function first. So let's specify 45 there. And if we print the sets variable, as you can see, 45 is no longer inside this set. But if you use the remove function here, it kind of just do the same as what it did in the discard function. So you might wonder, why do we need two functions if they are just working just the same? So basically, there's a distinct difference between these functions. So if you use the discard function, no matter what happens, even if the element that you specified in its parameter is non-existent inside the set, it will still run. Okay? So it will ignore whether your number, the number that you specified inside its parameter is non-existent or existing in this set. Okay, so if you use the remove function, actually it will throw you an error if the number that you specified inside its parameter is non-existent inside this set. Okay, so which is a good thing because you are going to be able to know um, what could uh, what could be the problem of what you did, or if the number is non-existent really inside this set. So let's do that. So let's say dot discard function, and let's specify the element that is not existing in this set. So let's say 50. So if you print this, it will still run even if 50 is not existing inside this set. But if you use the remove function, what will happen here is it will throw us an error because 50 is not inside this set. So this is basically just how you use discard and remove. Now let's proceed to the pop. Now when you use this, it actually just removes an element from the set randomly. Okay, so we have pop, and it will just have itself because it removes an element randomly inside the set. So if we print this, I think the rave has been removed. So let's run this again. Run this again, and the John now is um, no longer inside the set. So this is basically how you use the pop. So let's proceed to the clear. Now, when you use this clear, it will just give you an empty set. So let's use clear function. So let's print this, and basically you have an empty set. And those are the removing functions in sets. So let's proceed to comparing functions in a set. Okay, so this is more like the set in high school now. Okay, so let's talk about the difference function. Now, this has no difference on complement in high school. Okay, so it's going to return a set containing the difference of the set A compared to set B. Okay, set A compared to set B. Okay, so let's say we have a set A here, and this is going to contain a bunch of integers. Okay, so 1, 2, 3, 4, 5. And then we have set B as 1, 2, 3, 4. So what we know is the difference between these two are basically 5, right? But we need to set a model in order for us to work with difference function. Now, if you use the set A, it will indeed know that the difference between these two is 5. Because the set A has the 5, which is not inside the set B. So if we do this, let's say set C. So as I said, difference function is going to return a set. So we have set C as the returning set. Okay, so let's call set A as the model dot difference, and then let's put set B. So if we print this, this should give us 5, right? So we have 5. But now, if you use set B as a model, for example, you want to know the difference of the set B compared to set A. So the difference of set B compared to set A is none. Why is that? Because 1, 2, 3, 4 are actually included inside the set A as well. So if you print the set C, that's just going to return us an empty set. And this is basically how you use the difference. Now, what if you just want to get the total difference between these two? So you don't really care about the models and yeah, you don't care about that stuff. So what you do is to call what we call a symmetric difference function. Okay, so we have let's just call set A dot symmetric set B, symmetric difference function. So we have that. Now, if we do this, that's going to be 5. If you change this to set B as the model, it will still be 5. Okay, so this is basically how you use symmetric difference. All right. Okay, so let's proceed to the intersection. So we all know that when we talk about intersections, it is basically the element that is included to the another element. Okay, so in this case, we're not going to change the set anymore. So basically, the intersection of the set A and set B are 1, 2, 3, 4, and 1, 2, 3, 4, because 1, 2, 3, 4 elements are actually included uh, to both these sets. Okay, so let's call that out. So we have set A dot intersection. Oops, intersection. Okay, so let's call set B. So if you print this, bam, we have 1, 2, 3, and 4. So it doesn't really matter if you put the set B as the model, it will still give us 1, 2, 3, 4. Okay, so let's proceed to the last one, which is the union. Okay, which is the most common or normal topics in high school. So we have that. So we have set A dot union and then set B. So basically the union here is going to be 1, 2, 3, 4, 5 because that is the elements that are included in these sets. So we have 1, 2, 3, 4, 5. And basically this is just how you use the sets. So thank you very much for watching this and see you guys next time.